Namaskaram to everyone. I welcome you all for the Sanatan Dharma program for the youth. Today we'll have Goutham Mukherjee sir explaining the Vedic mathematics introduction. We have prayer by Atidi. After that, sir will be giving the lecture. Atidi, can you chant prayer?
शुक्लाम्बरधरं विष्णुं शशिवर्णं चतुर्भुजं प्रसन्नवदनं ध्यायेत् सर्वविघ्नोपशान्तये सरस्वती नमस्तुभ्यं वरदे कामरूपिणि विद्यारम्भं करिष्यामि सिद्धिर्भवतु मे सदा हरि ओं श्री गुरुभ्यो नमः धन्यवाद।
You want me to introduce Goutamji? Okay. Dr. Goutamji's he's MSc in Physics, Burdwan University, West Bengal, 1977. He's a PhD in Physics from Indian Institute of Technology, Kanpur, 1986. And he joined National Informatics Center, NIC, in 1990 and retired from NIC in 2016 from the post of Senior Technical Director. Although interested and tried to follow Sanatana Dharma all throughout, and interested in Vedic mathematics. So with this brief introduction, I request him to start the webinar, please.
Thank you. Sharing.
Yeah. Please go ahead.
Yeah. So earlier we started this introduction to Vedic mathematics. Thereafter we went for various, how the Indian arithmetic number system came up, and then we did this about this book I told. Then this book actually of Bharati Krishna ji from Atharva Ved. Actually, there are in the introduction he has written that those formula were very much scattered throughout, and it is his deep contemplation that in the maybe in the Samadhi state also, so he could decipher all these things actually. So in a way, this what is the Vedic sutras, 16 sutras and 13 sub-sutras, all are in a way it is a reconstruction, you can say. Somebody may think tell that where exactly it is these are written in this format in Atharva Veda. No, actually it is his reconstruction from the various scattered things, and he worked on that. He for the 16 sutras he had written 16 volumes, and unfortunately that is lost because somebody he gave to some his disciple to compile it or something like that, but he somehow missed it. Somebody has stolen, or I don't know exactly what happened, but those things actually he somehow again could something recall, and then he wrote that particular book. But this is actually not the full thing. So there I discussed this part. I discussed some certain and the vinculum concept we discussed, and how the vinculum can be used for various purposes. Then he came to different multiplication near base or sub base. And then we came to this called Nikhilam Navatastra Ramangtastra, and the algebraic explanation was also given. Then we came to another system of multiplication, which is actually it's called Urdhva Tirjaka, upward and cross. So this is a cross multiplication kind of thing. Nowadays it is being taught in all the different format. Some I found with some school student here with some square, drawing some square and some corners kind of thing. Basically, this is doing the same thing. Then we came to compare all these different multiplication methods, and the conventional method also was compared. And then we came to division. Division with single digit or multiple digits, and multiple digits, and these are some special cases were also there. Very special cases are also discussed. Like this, special cases of the no, this is the special cases of this is Paravarta method, and special case of Nikhilam method was also discussed. Then the sub-base technique, this is the special case of I'll let me make it. Right, so this is the about the Paravarta method, Nikhilam method. Then came here, came to that we came to what we came the Paravarta method, which is actually the opposite of that, which is that was below the earlier. It was below the base. Now it is above base. And what is that? Only the vinculum or the negative symbol is we used. And then these Paravarta methods are discussed, and then some special cases. How the sub of Paravarta method, you can say the sub base used in Paravarta method. So there are some halves and how to tackle the half. These also are discussed. And then I came to the there are different formats of decimal form, rational fraction, and decimal form. The division is done, and division was not to be stopped here, so it goes to these fractional parts expressed in different formats. And then what is the relation between these two kind of representation, and how to come to what is the decimal form decimal form, and what is the relation between these two. So, and then we came to concept different this transformation between one format to another. We shared the, I think we shared this PPT, and then we came to how the decimal expression can be done in Nikhilam, but it becomes pretty complicated, right? That's what was discussed. Then we came to Vedic online method. Vedic online method actually is applicable for denominator ending in 1, 3, for 1, 3, 7, and 9. For 1, 3, and 7, this can be respectively can be multiplied by 9, 3, and 7, so that the last digit actually ends up in 9. So we give the procedure to how to give the procedure for denominator ending in 9. We have to do Likhila the Ekadhikana Purvana. This for 1 has to be done with added to 1, 2. So that 2 has to be multiplied, 2 has to be worked with. It's called digit divisor. And with digit divisor, there is a procedure that we ultimately goes to like this. And this particular sequence I have shown that contains all the fractions, decimal fractions, from 1 by 19 to 18 by 19, all are embedded in this. We discussed how to go from 1, and finally it goes like that, 1 by 29, that's something by 29, and the algebraic explanation comes with the expression of 1 minus x to the power minus 1, binomial expansion. Basically, it is binomial expansion of 1 minus x to the power minus 1 one works out the algebra slightly, and then it finally comes to like this, how we are working with this one. Actually, this is the last one. The third line is actually our mystery behind solving the mystery behind the how the Vedic online method works. Then we came to that other denominators, and then finally one came where the if the denominator actually ending by 1, then it becomes very complicated. So we come to another procedure called the expansion of 1 plus binomial expansion of 1 plus x to the power minus 1, and it is actually coming to this one. So it is a negative method. So we also discuss how the negative method is coming and how to handle the vinculum here. Negative number divided by what is the quotient and remainders are very important points. What is the quotient and remainder to be calculated when we are dividing a negative number. So this all we have discussed. One can revise anytime. Now we come to these are all about this. These are over. The periodicity was also discussed, that how it is. It's called repeat 9. Repeat 9 numbers. If they are fraction of something, this 41 is a fraction of the 5 numbers of 9. So it actually something by 41 will have 5 digits. So these are all this actually explained here. Then today we come to the divisibility rules without the actual division. So these certain things are taught in our class, but not all. I'll discuss that which is taught and which is not. The numbers 2 and 5 are we have the decimal system with base is 10. And 10 has two factors, namely 2 and 5. So their behavior looks similar. So the numbers 2 and 5 have factors, they're similar rules actually. Divisibility by 2 to the power n, any power of 10 requires last n digits to be divisible by 2 to the power n. For example, 57356 is divisible by 4 because 56 is divisible by 4. And it is divisible by 4 means automatically it implies divisible by 2 also. These are factor of that. And similarly, divisibility by 5 to the power n requires last n digits to be divisible by 5 to the power n. This particular number is divisible by 25 because since 25, the last two digits are divisible by 25. So, for example, suppose whether this is divisible by 8 or not, we'll find that this is not divisible by 8 because 356 is not divisible by 8. Had it been 456, it would have been divisible by 8 also. Last three digits would have been. So 2q. So we have to look for three digits. If there is 2 to the 16, you have to see last four digits have to be checked. If we have to check for 2 to the power 4, that means 16. So that way actually. Divisibility by a composite number demands second category I'm coming. First was with 2 and 5, purely with 2 and 5. 2 or 5. The divisibility by composite number demands divisibility by its factors. For example, 42 is divisible by 6 because it is divisible by 2 as well as 3. So it is divisible by 2 into 3, which is 6. 135 is divisible by 15 because it is divisible by 3 as well as by 5. For 5, so this is ending in 5, so it is divisible by 5. And for 3, there is a rule. 5 plus 3 plus 1 is 9. 9 is divisible by 3. So it is divisible by 3 as well. So it is divisible by 15. The divisibility by divisors ending with 1, 3, 7 or 9. Mind these numbers, excepting 5, all the odd numbers. Not an even number, but odd numbers only, excepting 5. So this is 1, 3, 7 and 9 has general method of called osculation, which is a basic method coming from one of the sutras. Maybe that will go back for which sutra actually, but he mentioned somewhere, which gets trivial form in case of 3, 9 and 11 because there is something called osculator. The osculator is plus 1 here and minus 1 here. So you do not notice this. We didn't understand that this is from osculation method because it is so obvious. So come one by one. Sorry. Is it coming full screen? Are there some hindrances coming in this? You can see the
No,
whole.
sir.
You can read.
We can see, sir.
Yes. Now divisibility by 3. A number is divisible by 3 if sum of all its digits is divisible by 3. For example, this large number is divisible by 3 because the sum, if we sum all the digits, it becomes to 24. 24 is divisible by 3. Divisible by 9. Number is divisible by 9 if sum of all its digits is divisible by 9. For example, the number, this large number is divisible by 9 because sum of all its digits, 27, is divisible by 9. And divisible by 9 automatically will imply divisible by 3. But whereas the reverse is not true because this is more and this is less. Here 24, sum was 24. So it was 4, this 24 is not divisible by 9. So this large number is not divisible by 9, whereas it was divisible by 3. It's 3 and 9. Divisible by 11. A number is divisible by 11 if the difference of sums of alternative digits, say even and odd position digits, is either 0 or divisible by 11. For example, this number is divisible by 11 because alternative even positions digits minus alternative odd position digits, if we add up, is equal to 20 minus 9 is equal to 11. It could have been also 0 also, or 11 or 22, something. That difference should be divisible by 11, then only the whole thing will be, large number will be divisible by 11. Find whether any number, this exercise, you can see this exercise and whether these numbers are divisible by 9 by these methods. You can. Now we come to osculation method. What is osculation? A 2 or more digit number, it is actually algebra is discussed here. So if we want, we can skip this, but you can see the algebra, how we came to that. A number can be expressed in this format. And our procedure will be to segregate the unit with the rest of the numbers, like this. 10r plus u is the total number. Now we have to form a smaller integer called test integer is equal to this r without this 10. This r will be added to a particular oscillator plus multiplied by that oscillator plus that rest number, like this, r plus mu. Where the multiplier is called m, multiplier m is called oscillator. It is being said that the number n, integer n, is oscillated by this small m to get the test digit t. The process can be recursive. One after another we can do. When we actually go to that examples, we will be able to see. We have to form this t. In order to form this t, you have to know what is m for a particular divisor d. Unit digit t can be multiplied by m to add the rest of the digits to get the next t. And then it goes on like that. Osculation is an efficient method for testing divisibility by divisor ending in 1, 3, 7, or 9. It is a method to determine the required m given the number n and divisor d ending in 1, 3, 7, 9. The oscillator m can be found with the following consideration. Here actually, this is, you have to understand the procedure here. This is okay. That capital N, whole number is something like this. The rest of the digit and the unit is separated, and then with the rest of the digit except the unit, we add some multiplier into the unit digit and to get the test number. If the test number is divisible by the denominator d, divisor d, then n also will be divided. That is the idea. So it is 1, 3, 7, and 9. So the divisibility oscillation method, the algebra behind is this and this. Actually, you sometimes one can go through it. I may not discuss it. Algebra is very simple actually. By some logical induction it is done. If time permits, I may go back and come back and discuss it also. Now we come to the procedure. Let us test whether 343 is divisible with 7. First, we find oscillator for 7. This is the first task. We find that in case of 7, when you multiply it by 7, or 7 is supposed to be multiplied by 7, so that becomes something ending in 9. See, 7 into 7 is 49. Okay? And 49 is 10 into 5 minus 1. Therefore, this 5 will be oscillator. Not 7, not multiplied with 7, neither 4. This is 5 will be oscillator. Thus, oscillator is 5. Once found M, we execute the following process. 343 goes to 34 plus 3 into 5. It becomes 49. So 49 is divisible by 7. So again, 343 is also divisible by 7. Take 6, 4, 7, 7 to 4. 6, 4, 74. We cut it like this. We cut it like this. We segregate the unit digit, and then here you cut it, and then 6472 plus 4 into 5. The oscillator is 5. So this 4 into 5. So it is 6490. Again we cut here. 649 plus 2 into 5 is 659. Again that thing we cut it 665 and 9 into 5 110, and it becomes 110, 11, not divisible by 7. So by backtracking, all these numbers are not divisible by 7. Test divisibility of this by 13. Let us first find the oscillator M for 13. What is that? We find that for anything ending in 3, we have to multiply by 3 actually. So 13 3s are 39. So 39 is actually 10 into 4 minus 1, 39. So 40 minus 1. So divisible by 13. So it is divisible by 13. So therefore, M is equal to 4 for 13. We do what 11625, 65.
Sir, so if it's any other number, sir, if it's any other number like 16, do you multiply it by 6 to find the oscillator?
For 16?
For 16, do we multiply it by 6 to find the oscillator, or is it?
When you divisibility by 16?
No, sir, to find the oscillator of 16. Yeah,
Oscillator
divisibility of
for?
16. 16, do we multiply it by 6?
No. Oscillator for 16 has no meaning, because I told you the oscillator method is for?
Okay.
For oscillator method for ending in 1, 3, 7 or 9.
Okay.
16 is not ending. For 16 actually it comes to this category. 2 to the power 4.
Okay, yeah.
So it has direct category that last 4 digits. You see last 4 digits, whether it is divisible by 16 or not. That is the only thing.
Sir. Okay.
Now ending in 1379. Now, so for 13, it has to be. It's good question, so that you are attentively. If any doubt, you can ask anytime. As a 11635, so 1163 plus 5 into 4, because 4 is the oscillator, becomes 1183. Again we cut. So 118 plus 3 into 4, 130. And 130 is actually divisible by 13. We can see directly the 113 into 10. So you need not go to next step, or whenever you find that you see that directly it is divisible, you leave that, so that all these things are all divisible by 13. Test divisibility of this by 23. We find that again he multiply by ending in 3, multiply by 3. So it becomes 69. 69 is 10 minus 7 minus 1, 69. 69. Multiply this one, 69. So 10 into 7. 7 it becomes the oscillator. So therefore 41285 we do 4128 plus 5 into 7, 4163. Again that thing is cut here. This is 93 and 77, 92, divisible by 23. So therefore, all these are divisible by 23. Multiply number ending in 3 or 7 by 3 and 7 by 3 and 7 respectively to get oscillator. 7 into 7 by 6 for 17, it will be 12. Now you tell me what will be the oscillator of divisibility by 19, Aditi? Divisibility by 19, what will be the oscillator? I want to test divisibility of something by 19. What will be the oscillator?
Sir, I was on mute. It will be 171, which is 10 into 17
Why 171?
plus 19 into 9.
Why?
Yeah.
Why you are multiplying by 9? I told you that it should be, we have to make it so that it is ending in 9. So what will be the oscillator of 19? Think. I'm giving you some small time to think, so that you are following the procedure.
Sir, is it just 19 into 0? Because...
What 19 is 0? Why is 19 into 0?
Wait, no. 19 into 1, because then
what will be the oscillator?
have...
Finally, what will be the oscillator I want to say? See.
10 into 1 plus 9. So it will be...
Oscillator should be what?
It will be 1. The oscillator
1?
will...
No.
Mm,
You see the how you are doing. Here you see, it was 69. So we did 10 into 7 minus 1. Then 7 becomes the oscillator. We express 9 in this format, like this. 10 into something minus 1. 19 is equal to?
10 into 2 minus 1.
So what is the oscillator?
2.
2. Yes, not 1. 1 was the oscillator for 9, which is 10 into 1 minus 1. So we do not notice. I mean, oscillation is not taught in the school. The oscillator, the word oscillator was not taught. Directly we add up all the number. How you are adding up? Because it is multiplying by 1 all the time. Multiplying by 1 we do not notice. But here you have to multiply by 2. So let us see. I didn't put in the slide. Suppose I want to test whether I go to what screen. A number is there 8664. Okay. I want to see whether divisible by 19 or not. Here, oscillator is 2. Now, what is the procedure, Aditi, you tell me? What should I do first?
You'll get 866 plus 4 into 2, which is
Yeah.
887 4.
866 plus 4 into 2.
4 into 2, 874.
8. So 874. 874. From there, it come to where?
87 plus 8, which is 95.
95. So,
Yeah.
95, is it divisible by 19?
No, you'll get 9 plus 20. You'll get 29. You won't get 19.
9 plus
20.
5 into what?
Sorry, 5 into
How much?
5 into 2. 5 into 2. Oh, you'll get 19. Yeah.
Equal to 9.
Divisible.
So therefore, 19, 95. Suppose you know that 19 is stable. So immediately here itself, you don't have to go to the last step. Here itself, you can understand this is divisible by 19. Or if you do not, if you want, you can also go to the next step. Even you can go to the next step. 1 plus 9 into 2. What is? It comes back again and again. How many times? It doesn't matter. Every time it will come back to 19. So, therefore, 19 to 95, 874, 8664. All are divisible by 19. Okay, all are divisible. All are divisible by 19. Okay, you understand? Understood? You see, you did yourself. So when you do yourself, you understand better, no? Diti,
Yes,
what do you
sir.
say? What do you say?
Yes, sir.
Now come to next one. Now we come to positive, negative, and minimum oscillator. Problem comes when something is ending in 1. You have to multiply by 9, and it becomes a very large number. Earlier we have to in terms of the the function recurring decimal also we face the same problem. So here also it will be the same things. So we have to discuss about another concept called negative oscillator. So far we had the oscillator was positive. Now if 10m plus 1 is divisible by d, all the algebraic consideration holds good for oscillator minus m. It actually becomes negative. So the t should be calculated as r minus m u. And minus m is called the negative oscillator. The oscillator with minimum absolute value is called the minimum oscillator. And would be most suitably chosen to test divisibility. Always, we don't have to go for positive oscillator, but we can do positive, negative, and we can choose between positive, negative, and to get the minimum oscillator. Numbers ending in 3 and 7. Earlier, we told that number ending in 3 and 7 should be multiplied by 3 and 7 respectively, so that they end in 9 and we get the positive oscillator. But here I am telling the other way. Numbers ending in 3 and 7 have to be multiplied by 7 and 3. 3 ending in 3 should be multiplied by 7. Ending in 7 should be multiplied by 3, respectively, to get it. Example, 7 into 7 is equal to 10 into 5 minus 1. But 7 into 3 is equal to 10 into 2 plus 1. So 5 will be my positive oscillator, minimum positive oscillator, and 2 will be my minimum negative oscillator. 21 is divisible by 7. So 10 into 2 plus 1 is actually. So in case of 7 and in case of 9, we better to use negative oscillator. And in case of ending in 3 and 1, 3 and 9. Sorry, I told, what did I told? In case of 7 and in case of ending in 1, it is better to use negative oscillator. And in case of ending in 3 and ending in 9, we better to use positive oscillator. What do you, can you repeat all the three? What I told? In case of what? What oscillator?
Sir, you told in case of 3 and 7.
In case of ending in you can note down also. Ending in 7 and ending in 1. Because here you have to multiply it by 7 to get 7 to get the ending in 9. Ultimately, the ending in 9 is important. And here you have to
Yes,
multiply
sir.
by 9. It will be very big. Both are very big actually. So ending in 7, ending in 9, you use negative oscillator. And ending in what remains? What remains? What are other two?
In 3.
Other two?
In 3, ending in 3.
Ending in 3 and ending in 3 and ending in huh? 5 doesn't come here, this category. What are the 4 numbers I told? Excepting 5, all are odd numbers. So what is remaining? 9. So ending in 3 and ending in 9, because when you multiply by 3, we get ending in 9. Here, ending in 9 is important, ultimately. So ending in 3 and ending in 9 will come to ending in 9 when I multiply by 3 and itself. Multiply by 1 means it itself. So here, actually, you have to use positive oscillator. So you have noted down that ending in 7 and ending in 1, negative oscillator, ending in 3 and ending in 9, we use positive oscillator. I come back here. So 7, for 7 it is either 5 or minus 2. 5 or minus 2. I should use minus 2. So again, I can repeat all these things. Divisibility, here actually I have a large table has been given. So what is the oscillator? For a oscillator is +1 for these numbers. So you didn't notice, it is taught in our school, only this one is taught, this line. Only this line is taught to us. Because it is so easy. Oscillator is +1 or -1 here. You totally ignore this next clause. Divisible by 19 will not be taught. Divisible by 21 or divisible by 7 will not be taught. The 3 is a repeat. 3 comes here also. Just actually here it should not have appeared. It actually is already covered here. Divisibility, but it will work actually. -2 or for 3 also it will -2 will work. But why to use -2 when already this +1 is already there? Achha, so 19 and 21. For in case of oscillator will be 3 in case of 29 and -3 in case of 31 and so on. It goes like that. 13 you have already discussed. In case of 13 or 39 it is +4 and in case of 41 it is -4. That way it goes. Now we come to how to use negative oscillator. Testing divisibility of 8 for this large number with 7. We could have earlier showed how to use with plus 5. But here we will be doing with -2. So therefore, what we do, this is actually, it is more easy actually to find that handling multiplying by 5 is bigger and multiplying by 2 is easier. So this we do -2 by 2. Moreover, it will be reduced faster. It becomes. Huh? Already got it, na?
Yes, sir.
Minus
But
2 by 2 is this. Comes to this. Again, this minus. I cut it here.
Chalo, 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 chalo.
8 4.
sir, it wasn't me, sir. Someone
Achha,
else is on me.
No, chalo,
okay, this one, no problem. Oh, no problem. Achha, 8 4 1 4. Again, we cut it. So the 8 4 minus 8 is this one, 833. Again, you cut it here. 83 minus this one is 77. 77 is divisible by 7. Also, you could have done actually 7 into 7 minus 7 minus 7 into 2 is how is equal to minus 7. It could be sometimes it could be 0 also. Minus 7 is also divisible by 7 or 0 or in the negative it can come to 0. 0 also will do same thing. Like for 11 we also took 0, so that way this also 0. So this will be you got it now, Aditi? How you are coming? All these
Yes,
things are divisible by 7. Note that divisor ending in 1 or 7, it will be easier to use negative oscillator instead of positive oscillator. For example, in case of 21, negative oscillator 2, but positive oscillator 19, because it is. In case of 21, its negative oscillator is minus 2, but positive oscillator is very big. 10 into 91 is 18.
yes, sir.
Hey, sorry, 19. Oh, I'm sorry. Huh? In case of 19,
Sir, 63 or 7, no, sir.
Yeah.
No, not 63. 7 7s are 49. It would be no, sir.
Oh, yeah. In case of 21, it's not 19. In case of 21, oscillator itself is big, 19. So multiply by 19 and adding. Again multiply by 19 and adding. So this is like this. In case of 21, the oscillator is 19. In case of 29, it will be, in case of 31, it will be 28. In case of 41, it will be 37. So this will be all very big number, but when you use negative oscillator, in case of 21, it is minus 2. In case of 31, it is minus 3. In case of 41, it is minus 4. So big, small numbers, isn't it? In case of 17, either you can do 10 into 5 plus 1, which is minus 5, or 10 into 12 minus 1, which is plus 2. Here, if it is minus here, it will be m will be positive. Here it is plus here, m will be negative. So either you can do minus 5 or 12. Better to use minus 5. The criteria of divisibility using negative oscillator becomes either 0. Here it may be 0 also. Either 0 or divisible. In case of positive oscillator, it will be always divisible. It never will come to 0 because nothing is subtracting. Here it is subtracting, so there is also possibility of coming to 0. Like in case of 11, you have seen.
Yes, sir.
Okay. So this is like this. Now we come to divisibility of composite number. By composite number, we have to see the divisibility separately by two different components. See divisibility by 92 and 93. To test whether 8,456 is divisible by 92. This 92 is actually 23 into 4. So separately you have to see. This particular number is divisible by 4 because 56 is divisible by 4. And oscillator of 23 is 7. So it is, we go to like that and find that comes to 69 and it divisible by 23. So therefore it is divisible by 92 also. To test whether 8556 again is divisible by 93, we find 93 is equal to 3 into 31. So it is divisible by, this is divisible by 3 because when you sum up all these numbers, so this is divisible by 3. Oscillator of 31 is minus 3 because it is 30 is actually 33 into 10 plus 1. So oscillator is minus 3. So we do like this. We do oscillation procedure. Comes to 62, it is divisible by 31. Therefore, this is also divisible by 3 and 31 both, therefore by 93. So this is number, specially it was chosen so that it is both divisible by 92 and 93 also. Now we come to forget about this, what is written in very small thing, it is something else actually came by some other sort. Divisibility, multiplex oscillator method. Sometimes what happens, something is nearing to a 10 to the power something. And multiplication of that thing. So we use multiplex oscillator. Actually, before that, let us practice. Have some more practice. Already, can you do this thing? How whether this number is divisible by 59? How will you do? Let us see. What do you do?
Sir, it will be 60 minus 1. 6 into 10 minus 1. No, sir.
So oscillator is
6.
6. So what do you do?
40179 plus 1 into 6. So 6. You'll get 40185.
40185, isn't it?
Yeah.
And then we come to how much?
4018 into 30, I mean plus 30. So you'll get 4048, which is again 404 plus 40, which is 444.
Huh? 40 plus
444.
48. 8 into 6, no?
Sorry. Yeah, 48. We'll get 452.
Then 45 plus
45 plus 12, which is 57.
57.
Yeah. You'll get 5 plus 42, which is 5 plus, sorry, 5 plus 28, which is something.
It is not divisible by?
Yeah.
It is not divisible by.
Yeah. Guruji, but how will you know where to stop? Like, you can get 5 plus 20, not 28.
No, it will become
42.
obvious. No, it becomes 57. So 57, you can see easily that it is not divisible.
Okay. Yeah, it's lesser than.
It will be evident. You'll be
59.
able to see it. That is the thing.
Yeah.
Okay, you do this one. You do this one. 31. Oh, sorry.
It's 10 into 3 plus 1. So.
It is a little big one.
5 plus.
Anyway, what do you know? What is the first of all? What is the oscillator?
3.
Huh? 5464 85 5464 8545.
54 plus 5 into 3, right? So
5 into 3 is how much?
15.
Now we add or subtract?
Subtract.
You
will
For
get
31, the oscillator is actually, this is 30 is equal to 33 into 10 plus 1.
Yeah.
So if there is plus here, it will be minus. So it is minus 3.
Yeah.
So here you do 5. That way you do. Okay.
Yeah. 5, 4, 6.
You will be able to do it.
Yeah. You'll get 9. Wait, sorry.
39.
39. Yeah.
So that way it goes. Actually, it will be soon. It will be collapsed too.
Yeah.
Now you do it. This is smaller number. You do this one. 17.
Yes.
17. For the oscillator?
20 minus 3. I mean, it's 2, right?
17, not 17. Multiply by how much? If it ending in 7, should be multiplied by what?
7.
No, it will give a bigger positive oscillator. In case of 7, multiply by how much?
3.
3.
So you'll get 1.
This is the first procedure. This was ending in 9, 1 doesn't have problem, but ending in 7, 3, 7, 3, these will be, you have to consider. So 7 into 3 is 51, which is 5 into
10 into 5 plus 1.
10 plus 1. So therefore, this oscillator is minus 5.
Yeah.
So what you do?
You will get 6, 7,
6, 7,
2,
4, 2, then
minus 25.
minus 25. Yes.
Yeah. You will get 7. 11. Yeah. And
now
7,
again?
Yeah. You will get 6, 7, 2, 1 minus minus 35.
Minus 35?
Yeah. Right. Eight.
Like this?
Yeah, 6, 6. Yeah. You'll get 668 minus 30, which is 638. 638. So you'll get 66
30?
minus 30. So you'll get 638. You'll get so 63 minus 40. You'll get 23. 23. 2
So it is
minus.
not divisible by 70.
Yeah, you'll get minus. Otherwise, you'll get minus 30.
As soon as you see 23, you find that it is not divisible by 70.
Yeah.
So that way you try all these things, or you try some bigger number, even by calculator you can do a bigger number. Or Shogandiji can give you a number.
Yes,
a
sir.
number you can check whether things. You yourself can form a number either divisible or not divisible. Multiply by that number, you add some number so that it becomes non-divisible. Then you try this thing and so on. You can practice this. So you know at least you're confident that now you'll be able to do it.
Yes, sir.
So in case of 23, what you do? 23, this one.
Multiplied by 7. So
Let it be homework, Gautam ji.
Multiply by 7, no. Multiply, in case of 3,
yes.
multiply by 3. It becomes
Oh,
69.
okay.
If you multiply by 7, it will be very, very bigger.
Yes, sir.
3, it becomes 69, no?
Yes, sir. Yes.
See, 23 into 7 is how much?
Gautam ji, let them do as a homework. Any doubts?
Now, just I want to have. So 23 into 3 is 69, which is smaller, no?
Yes, sir. Yes,
Obviously,
sir.
it will be smaller. It will give you
Yes,
smaller.
sir. Yes, sir.
Okay, is homework. So you
Yes,
understood at least, no?
Yes, sir.
You form your own this thing, and so actually multiply this thing. You can do both, and finally you see that which is smaller. Now I
Yes,
come
sir.
to multiplex oscillator. Multiplex oscillator.
We
So it
have
is like this.
uh,
So it is like this actually. This consideration is same for this one. The actually for divisor of the form, see 199, 299, 399. We could have taken oscillator as 20 into 10 minus 1, 30 into 10 minus 1, 40 into... Now actually you can do, instead of that, we do like this. 2 into 100 minus 1, 3 into 100 minus 1, 4 into 100 minus 1. As multiplex oscillator and take 2 digits at a time. Let us say whether this one is divisible by 299. Then the second order oscillator is 3 because it is 300 and 300 minus 1.
Gautam ji, I think this is a new topic we are starting now.
No. This is the continuation of that.
Continuation means it may take.
It will not take much time. The only that I have to see that you first group in 2. Earlier you had single, no? Now you group into 2 and then you follow the same procedure. It will collapse very fast. This is actually divisible by 499 or not. So you group into 2 from right, and then this is actually 5 into 100 minus 1. So oscillator is 5 plus 5. So we do the similar thing we did, but with 2 in a group. See, such a big number collapses very fast and comes to this.
Yes, sir.
Then actually this is for 1. It finds that 4 is 400, 4 into 100 plus 1. So it is group in 2 and then minus 32. It is 32 over there. This 32 minus 4. So it becomes every time this 61 again you cut minus this minus 4. Again you cut it 2 at a time. 2 at a time. This one you cut it.
So if it's like a bigger number, we should
bigger number. So
be
it is
able
a suppose this divisibility is some power of 10. Multiplication of not only 10, multiplication of some power of 10 plus or minus 1. It goes like that. Okay.
Yes, sir.
Now come to, there is something called repeat 9 numbers. 99, 99, 999, 4 nines. How to see the divisibility? You group into group. Earlier for 9 we used to, what we used to do? For 9 we used to add all the numbers. Now we'll add, but in group of 2 in case of 99. See how it is interesting? Okay. This we divide into group into 2. From right, not from left, from right. And elaborate. So this becomes 99, so it is divisible. Here you group by into 3. Here you group by 3. It is called repeat 9 numbers. This number is 99, so divisible. This also is this one. Okay. So repeat 9 numbers are special cases where nth order multiplex oscillator is 1. Like in case of 9, it was simple addition was 9. But it was first order was 9 in case of 9, but it is second order is 9. Second order is, sorry, in case of 9, it was oscillator was 1 plus 1. First order. Here is second order is 1. It is third order is 1. Fourth order is 1, and so on. In case of hollow numbers, generally called hollow numbers, 10 to the power n plus 1, like 1001, 101, 1001, 10001, like this. Here, like in 11, we group into two plus, minus. Here also group by into plus, minus, like this. See, plus or minus becomes total unit, not divisible. This is actually 1001. This is actually, I group from right, but again do plus, minus, and then becomes 0, 0 or this number. Here can, because it is negative, subtracting also becomes also negative. We can come to 0. This one, such a big number. So you group into 4, 10 to the power 4 plus 1. Group into 4. Plus, minus, or it is 0 should be 0. Hollow numbers are special cases where nth order multiplex oscillator is -1. Thus the process leads to alternate addition and subtraction of digits grouped in n. Like what we did in case of 11, it was single actually. Or 10 to the power 1 minus 1 it was. And it was 10 to the power n plus 1. So divisibility, multiplex oscillator, others. Factorization of this, arrive in these things. Like this, divisibility by 857. How it comes? Now we have to find that 7 into 857 is this. So third order was oscillator is 6. Third order positive oscillator is 6. Because 6 into 1000 minus 1. So oscillator is 6 for third order. So you have to group into 3. Here it is group into 4. Divisibility by 2333. It is actually 6999. So divisibility will be fourth order oscillator. Group in 4 is 7. Like this. So just it is better to know just it is there. Now we come to this is a second level course. Clear? This part is clear also. Multiplex oscillator. It collapses very fast. Especially this one will be very interesting. Okay, we end the lecture. Any question?
No, sir. It was very interesting, sir.
Yeah.
Actually.
This one actually just this PowerPoint presentation is shared. You go through this one and in any part you can
Yes, sir.
replicate. You try.
Yes.
Huh?
Yes, sir.
Okay, thank you, Namaskar. It had been interesting. So there is especially no other question excepting this one. What should I try slightly?
Thank you very much, sir, for sharing your valuable knowledge with us. Thank you, sir. Now, Atiti will be chanting the prayer.
Sarve bhavantu sukhinah, sarve santu niramayah, sarve bhadrani pashyantu, ma kaschid dukkha bhag bhavet. Om Shanti Shanti Shanti. Hari Om Shri Gurubhyo Namaha.
So we all stand for the national anthem.
Yes.
Janagana Mana Adinayaka Jaya He Bharata Bhagya Vidata Punjab Sindhu Gujarat Maratha Dravida Utkala Vanga Vindhya Himachala Yamuna Ganga Uchala Jaladi Taranga तव शुभ नामे जागे तव शुभाशिष मागे गाये तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद. Thank you.